All right, this is page 244. And on this page, we're going to learn about prime factorization. It says finding the prime factorization of a number. Pay attention to this word prime there. Prime means a number who has only two factors, one and itself. So that's what we're going to be doing, is identifying prime factors. Read along with me. The prime factorization of a number is the number written as the product of its prime factors. For example, the prime factors of 12 are 3, 2, and 2. Now some kids would look at this statement right here, and they would not be able to make sense of that. So what I'm going to do here is I'm going to prove that to you. I'm going to make a little space. I'm going to cover this up. I'm going to show you how this works. So we're trying to find the prime factors of 12. So you put a 12 here, and then it's 12 prime. It's not. So what I do is I write out some factor branches. And so what I do on these factor branches is I just pick any two numbers that make the statement true. Is 2 times 6, is that true? 2 times 6 is equal to 12. It is. Now what are we looking for? We're looking for the prime factors. 2 is prime because it only has two factors, 1 and 2. 6 is not prime because it has lots of factors. Well, how can I make, and since 6 is not prime, I branch it. How can I make the factors of 6? Well, I can just choose 2 times 3. Now, is that true? Is 2 times 3 equal to 6? It is. And what's also true about that is that 2 is prime and that 3 is prime. So just a minute ago, we read this statement that said the prime factors of 12 are 3 and 2 and 2. And I've got a 3, a 2, and a 2. And it makes 12. Watch. 3 times 2 is 6 times 2 is 12. So that's how prime factorization works. Now we're going to go ahead and go through this bookwork. A says, or the directions say, use a factor tree to find the prime factorization of 40. A says, list the factor pairs of 240. I'm going to help you with this because they get really kind of obnoxious. Like, for example, the first pair would be 1 times 240. That we can't use that fact on a factor pair. Or we could do 2 times, it's 120. Or we could do 3 times, it's going to be 80. 3 times 8 is 24, so therefore 3 times 80 is 240. Or we could do 4 times 60, because 4 times 6 is 24. We could do 5 times, and I know 5 goes into 240, but I'm not sure how many times, so I'm going to divide 240 divided by 5, and I get 48. I could do 6 times 40. I'm going to stop there. That's enough. Let's just do dot, dot, dot. There's a lot more, but we really don't need to list all of them. I don't want you to waste too much brain power on this because listing all the factor pairs in prime factorization actually isn't important. So I want you to notice, it says right here, choose any factor pair to begin the tree. What you can't do, let me fix that real quick. You can choose any factor pair except for one. So you could begin the tree this way. You could write 240 at the top, and you could do 2 times 240. It's not 240, it's 2 times 120, sorry. 2 times 120. Because 2 times 120 is 240, you could start it that way. Or you could start it this way, 240 on the top. You could do 3 times 80. I want you to notice that these pairs right here, I'm getting from right here. And this pair, I'm getting from right here. So there's different ways. You'll get the same answer as your peers if you start your factor tree a different way. As long as your facts are right, you'll get the same answer. So we choose any factor to begin the tree. I want you to notice that the book chose this one right here, 5 times 48. Do you see this 5 times 48 right here? That's the way they chose it. And the reason I know that's because they put 48 here. Well, there's only one statement or only one number that makes that true. It's 5, and I can prove it to you. 5 times 48. If I wanted to choose, like to put a 2 there, it just wouldn't be true. 2 times 48 is not 5 or 240. So this spot right here has to be a 5. And then I'm going to show you the words, the rules here. It says if a number in this pair is prime, circle it. 5 is prime because there's only one factor besides itself, 1 and 5. There's no other numbers that divide evenly into 5. So we circle it. And when you circle a number, then what you don't do is branch it. When a number is not prime, then you branch it. So they did branches for us, 48. Now we start over here by thinking about the factors of 48. Since 48 is an even number, my favorite way to do it is just to put 2 as one of the factors. Does 2 go into 48? Yes. How many times? 24. Now examine your numbers here. 2 times 24. 2 is prime. 24 is not. So you put some branches. What numbers can go here and there? Well, I like to do 2 again because it's an even number. 2 and 12. Is that true? 2 times 12 is 24. It is. Circle the 2 because it's prime. Branch the 12 because it's not. What makes up 12? 2 times 6. We actually did 12 earlier. 2 is prime. 6 is not. What makes up 6? 2 times 3. 2 is prime. 3 is prime. Now I want to show you something kind of interesting. Pay attention to these numbers right here, these prime numbers. I'm going to punch it into a calculator. I'm going to start right here at the 3 and I'm going to work my way up to the 5. 3 times 2 times 2 times 2. How many 2's are there? 1, 2, 3, 4 2's. Times 2 times 5. This problem, 3, 2, 2, 2, 2, 5, is this problem right here. This better be, when I hit equals, it better be 240. And it is. So that proves we got it right. So I'll read the rest of the directions because we did it. If a number in the pair can be written as the product of two factors, draw additional branches. We did that. And write the factors. Continue adding branches. We did that. Write the prime factorization of 240. You could just go in order 5 times 2 times 3. What we actually do though is we try to go in order least to greatest. So the least number here is 2. And there are, and I'm going to use dots instead of x's. There are 1, 2, 3, 4 of those. 2 times 2 times 2 times 2. And then the next least is 3. And the next least is 5. So that's the prime factorization. And then the next step is we really like to write the prime factorization using exponents. Which of these appears more than once? The 2 does. 2 is the base, and there are 4 of them. So it's going to be 2 to the 4th power times 3 times 5. That is how you write the prime factorization using exponents. They gave us kind of a tricky number, so it ended up being, kind of it's not a tricky number, it's just a bigger number. So it ended up looking kind of confusing. Let's go to the reflect. Reflect number 5. What will the factor tree for 240 look like if you start the tree with a different factor pair? Last time we started with 5 and 48. And we ended up with a certain, what we ended up with when we were done. In fact, I probably should show you both. I think I'm going to try to show you both. So I'll do the same thing I did before. I'm going to go as fast as I can. This is 2 times 24. This is 2 times 12. This is 2 times 6. And this is 2 times 3. And so what did that equal? It equaled 2 to the 4th power times 3 times 5. What this is asking you to do is do the same exact thing to find the factors of 240, but choose a different starting point. Choosing a different, it says start the tree. Look at what it says right here. It says start the tree with a different factor pair. So I'm going to start my tree with 240, but I'm not going to do 5 times 48. I'm going to do, I don't know, I'll just do 4 times 60. Is that true? Is 4 times 60 240? Of course it is. 4 times 60 is 240. I knew that because 4 times 6 is 24 and then annex is 0. Neither 4 nor 60 is prime. So I'm going to take 4 and I'm going to branch it and make it 2 times 2. Is that true? 2 times 2 is 4, yes. And they're both prime. Now I got to do 60. And I'm going to do 2, which is prime, times 30. Now I got to do 30, which is, I can do 5 times 6. And I'm going to do 6, which is 2 times 3. Both are prime. All right, now count them up. I've got 1, 2, 3, 4 2's, a 3, and a 5. So I've got 4 2's, that's 2 to the 4th power. I've got a 3, and I've got a 5. And what you should notice is that it's exactly the same. What we want you to recognize here is that if I start my factor pair with a true statement, 5 times 48, and you start your factor pair with a true statement, 4 times 60, you end up with the same terms as me. Your path looks different and your tree looks different, but you get the same exact terms as me. So we got to write that. The trees look different. I'm going to call them factor trees. The factor trees look different but you end up with the same prime factorization. Or I will say you end up with the same prime factors, but you end up with the same prime factors. Nice. Great job. You are successfully done with page 244. That's your introduction to prime factorization. Nice work.